So in addition to balancing reactions, one thing that you can do is also categorize them into several general categories of reaction types. All right. For the first four of these, a lot of times I give a relationship analogy because I think that if you understand the relationship, what goes on in that, it's easy to see how it's happening in the chemical reaction. All right. So the first of these reaction types is what's called a synthesis or combination reaction. All right. And this is when you have two or more either elements or polyatomic ions coming together to make one. All right. And so I always make the relationship analogy, think about marriage. Two things come together to make one. All right. In this right here, in this particular reaction, notice in the beginning you have the magnesium and the oxygen, which are separate. And in the end, they are part of one compound. All right. So generically, we could say that this is A plus B yields AB. All right. The next type is called decomposition. All right, this is when a chemical everything is together and in the end it's broken apart. All right, the relationship analogy would be divorce. All right, so in the beginning you have, barium chloride right here, and in the end you have separate barium and chlorine. All right, so generically, a decomposition would be AB yields A plus B. All right. The next one is what's called a single replacement. All right, and this is where one element or polyatomic ion replaces another. All right, I didn't come up with this term, but some of my students a couple years ago referred to this as a high school rebound, and this is just the terminology that I've used since. Imagine you've got a couple and you've got someone who's single, and all of a sudden later there's a different couple and there's somebody left out. All right, so in this particular reaction, you've got barium all by itself, you've got hydrogen and fluorine that are part of a compound. In the end, notice that you've got just a new combination. You've got barium and fluorine together and hydrogen is all by itself. So that would be a single replacement. All right, and the last of these types of reactions is a double replacement. All right, and this is where two elements or polyatomic ions switch in a chemical reaction. And even though I don't know of this relationship analogy ever really occurring, but there was a reality show a couple years ago that gained popularity where they deliberately switched the couples and they followed their lives. I don't know how long it lasted, but it was an amusing reality show. So the analogy kind of stuck to this particular reaction type where the partners essentially switch. All right. So in this reaction right here, you can see barium and chlorine are a pair. Here we've got ammonium and carbonate as a pair. And in the end, you can see that the ions have switched places. All right, so generically, we could say that AB plus CD would yield AD plus CB. All right, so the last type of reaction that you're responsible for recognizing is a combustion reaction. And combustion is just a fancy way of saying burning. All right, it involves a fuel molecule. And the fuel molecule generally contains carbon and hydrogen, but it sometimes contains oxygen. And it reacts with oxygen to make carbon dioxide and water. All right, and so generally a lot of, and I should say, heat is generated when you have these. All right, so if you've ever, this is like essentially whenever you burn something. Whenever you burn something that is required is something to burn. That's going to be your fuel. You need oxygen. All right, if we don't have oxygen in the air, we can't, the reaction can't take place. And what you end up making is carbon dioxide and water. All right, and you can see that sometimes this fuel contains oxygen and sometimes it doesn't. All right, for example, the type of fuel that your car uses is gasoline. All right, that is a hydrocarbon. It just has carbon and hydrogen. All right, there's no oxygen in that fuel. All right, but the type of fuel that your body burns is generally a form of a glucose polymer. All right, and glucose does have oxygen in it. It's a carbohydrate. All right, so but whenever either of those materials gets combusted, it requires oxygen as a reactant, but it makes the same products, carbon dioxide and water. All right.